Anyone? Hello? Am I audible to everyone? Yeah, so what I was asking, do you anyone of you have idea how to trace a curve? Okay, I think I cannot unmute you guys because sir unmuted you guys. So I'll be just sharing the screen, okay? And if you are facing any difficulty there, you just give in the chat box what are the problems if you are not understanding anything. Is the screen visible to all? Okay, okay, fine. What are the types of curves? Okay, so basically you will have total three types of curves there. First one is the Cartesian, polar, and parametric. These are the three types of curve we'll be going to trace. So first of all, we are moving into the Cartesian type of curve tracing, how we can trace those corresponding curves. Fine. So the first curve is given as this. So first of all, when you are tracing a curve, you need to find the points where the curves are becoming zero, right? Hello? Is it clear? Anyone just write in chat box. क्या हो रहा है? Okay. So first of all, we need to find if the curve passes through origin or not. So how can you do that? So basically, if you put x equals to 0, eventually you are getting y equals to 0, because x equal to 0, this is basically implying that y is equals to 0. Why? Because if you just substitute here, you will get. So the first point I am noting that the curve passes through origin. This is the first point you have to observe, by from which point the curve is passing. So for that, what you have to do, you have to substitute x equals to 0, and you have to check whether you are getting y equal to 0 or not. Secondly, you check what y equals to 0 implies. So basically x equals to 0, this is implying that y is eventually have to be 0, right? But if you put y equals to 0, what are the points you have in? X equal to 0, comma 3a. So basically the curve does not only passes through origin, but also passes through the point 0 to 0 as well as 3a. So there are 2 points the curve is passing through. One is origin, another is 3a comma 0. Is this clear? Is this clear? equal to 0, then you check what are the corresponding values of y. Then you have to check y, you have to substitute y equal to 0 and check what can be the corresponding values of x. Okay, so then you will get some points by which the curve is passing. This is the first idea. So after you have done that, what you have to do, after you have done that, you have to check the symmetry of the curve. So how can you check the symmetry of the curve? All you know about even function and odd function. I hope all of you know about even function as well as odd function, right? So what is the idea of even function as well as odd function? It is very clear that if you put f of minus x equal to fx, then you say the function is even, and f of minus x equals to a minus of fx, then you say the function is the odd function. So to check the symmetry, you have to check whether the what kind of function the curve is having. Like if you put y in place of minus y, okay, if you put y in place of minus y and you check the curve remains same or not. If you put y equal to minus y and you can see that the curve is remaining same, then you can say the curve is symmetric about which axis, x or y. Anyone type in chat box x or y. It's x-axis or y-axis? Yes, x-axis. So basically in this curve, if you substitute if you substitute y equal to minus y, you can see very clear, you can observe that the curve is remaining the same. So third point, you have to check the symmetry. If you put x equal to minus x, the curve is changing. So the curve cannot be symmetric about y-axis. But if you substitute minus y, then same curve. So this implies that the curve is symmetric about which axis? X-axis. So when you are tracing a Cartesian type of curve, first what you are doing, you are finding the particular points from which the curves are passing. Okay, so basically you can see we have 2 points there, 0 comma 0 and 3 comma 0. After we get this, what we are doing, we are checking the symmetry of the curve. How can we check the symmetry of the curve? If we substitute x equals to minus x, we can see the curve changes. So there is no symmetry about y-axis. But if I substitute y equal to minus y, then I can see very carefully that the curve remains same. So the curve is symmetric about x-axis. This is the first thing. So what is the next step? So first you have to check these three things. Then you have to check the equation of the tangent. So is there a tangent in the origin? How can you check that? Any idea? Fourth point, you have to check the tangent if there is a tangent at origin. So any idea how can we check the tangent at origin? So I'm repeating, while we're checking the tangent at the origin, you have to get the lowest degree terms, right? You have to get the lowest degree terms. Yeah, by taking derivative 0, that is the slope. That is the slope. Okay. What you are telling about tangent, that is the slope you have to take. That is very intuitive process. So basically when you are having this type of typical curves, what you can do, you can just find the lowest degree terms and equate them to 0. If you get the lowest degree terms equal to and equate to 0, you can easily see get the tangent at the origin, and you will obviously see that the tangent is passing through origin. So I'll just show you here. So how to find the tangent origin? I am writing the curve explicitly for you. So this is the basic explicit format of the curve. Right? If I break it down explicitly, this is the format. So what I am saying, I am taking the lowest degree terms and equating them to 0. So what is the lowest degree term here? Second order terms. So 3x square and ay square. These are the two lowest terms. So I am basically equating them to 0. So you will be having y equal to plus minus 3x. Okay. So obviously y equal to plus minus 3x, as you can see, it is passing through origin. Is it clear or not what I am doing? Is it clear? Is it clear? So is it the idea clear? How? Okay, fine. So after we are getting y equal to plus minus 3x, these are the two tangents that are passing through the origin. Okay. So as I have told you earlier, I have to find the particular points. So I have seen that x 0 comma 0 and 0 comma 3 are the 2 points. Okay. So basically you have the idea, it cuts the x-axis at the point 0 as well as 3a. Now you have to check the next, you have to check the region and the asymptotes. Okay. Now can you tell me what is the region of this curve? Any idea? What is the region of this curve? Any idea about the region of this curve? So you can see very carefully, the region of this curve is from minus a to 3a. Why minus a to 3a? So I am suggesting you are putting some value here. So if x is less than minus a, so if you put x is less than minus a, you are having y square equal to some negative number. Similarly, if you put x greater than 3a, you are having the same y square some negative number. Now as we are dealing with real curves only, the value of x and y, the value of x and y, this should be obviously real. So for x greater than 3a and x less than minus a, what we are having that y square is negative. But from minus a to 3a, all the values are real values, right? So the region of the curve is within minus a to 3a. This is your region of the curve. Within this region, the curve will get the corresponding values. So this is the fifth point. You have to find the region of the curve. And finally, we are moving on to the asymptote part. So do you know how to find the asymptote? So we'll be discussing about the asymptote. So can anyone tell me, is there any asymptote parallel to y-axis in this curve? Is there any asymptote parallel to y-axis? This is the curve. Is there any asymptote parallel to y-axis? Anyone? Anyone? Anyone please type. Can you find the asymptote parallel to x? Yes, asymptote parallel to y-axis x equal to minus a. Okay, the asymptote parallel to y-axis is nothing but x equal to minus a. So is there any asymptote parallel to x-axis? Is there any asymptote which is parallel to x-axis? From here you can easily check. This is the asymptote which is basically parallel to the y-axis. So is there any, okay, why there is no asymptote parallel to x-axis? Anyone tell me? So this is the asymptote, only asymptote parallel to y-axis is x equals to minus a. From here you can check, from here you can easily verify it, and there is no asymptote parallel to x-axis. And finally we are checking, is there any oblique asymptote? So first of all, what is the this quantity phi 3m? What is the value of this quantity? What is the highest power of y here? Yes, yes, right, correct. As x tends to infinite, y does not tends to a finite number, correct. And is there any oblique asymptote? Is there any oblique asymptote? Do you have any idea what is oblique asymptote? Anyone? Okay, fine. Do you know what is the value of phi 3m here? What is the value of phi 3m here? How it is coming? Does anyone know how I am selecting this phi 3m? How I am selecting this phi 3m? If anyone does not know, please tell me no. Then I can understand that you are getting it or not. Since it is all of you are muted here and I'm unable to fix it, so I'm requesting, if you are not getting something, just type in the chat box no, so that I can understand you are getting it or not. Just anyone type yes or no. Too difficult here. Okay, fine. Okay, I am telling you. The idea is that you have this y square into a plus x, and this is x square to 3a minus x. Okay. So what you have, how you are checking the phi m? So first of all, what you are doing, you are checking from which points the curves are passing. You are next checking that what is the how the curve symmetry is. So basically this is symmetric about x-axis, because if you substitute y equals to minus y, you are having the same curve. Next, you are finding tangent and origin. How you are finding the tangent and origin? You are equating the lowest degree terms and making it 0. So if you equate the lowest degree terms and make it 0, you can see y equal to plus minus 3x, which is the tangent at origin. Okay. Next, we are checking the region of the curve, which is minus a to 3a. So you can see when x is less than minus a, you are having y square as a negative number, and similarly for x greater than 3a. So the region of the curve cannot be for x less than minus and x greater than 3a. These two are not the regions of the curve. Okay. So what is the region? It is minus a to 3a. Again, we are checking for the asymptotes. The asymptotes parallel to x-axis nothing but y-axis nothing but x plus a equals to 0. There is no asymptote parallel to x-axis. We up first do up to this, then we'll be discussing about the oblique asymptotes. Okay, so first you tell me, did you get up to the asymptote part? Because it is becoming difficult for me to explain since I cannot hear you guys. First tell me up to asymptote part. I'm not going for the oblique asymptote right now. Up to asymptote part, is there any problem? If there is no problem up to the asymptote part, I am giving you a curve up to what you do, you trace up to the asymptote first. The drawing of the curve will be doing later. First, for you, what you try to do, you try to find the points whether it is symmetric, and you find the asymptotes and tangents at origin for this curve. So first tell me about does the curve is the curve passing through origin or not? So first tell me this curve x square y square into a square into y square minus x square. Does this curve passes through origin or not? Yes, it passes through origin. And any other point except origin from which the curve passes through? Any other points? If you put x equals to 0, you are getting y equal to 0. So eventually if you put y equal to 0, you are also getting x equal to 0. So basically there is no other point except origin. So the first observation about this curve is passing through origin. So the first observation is complete. Second observation about the symmetry. So can you do this for the symmetry? Is the curve symmetric about x or y or both? Tell me. Yes, correct. It is symmetric for both axes, because if you substitute x equal to minus x, you are getting the same curve. Also, if you are getting y equal to minus y, you are getting the same curve. Okay. So now the trick, next you have to find a tangent at the origin. So what is the trick for tangent at origin? I have told you, you equate the lowest degree terms equal to 0. You equate the lowest degree terms equal to 0. So here the lowest degree term is how much? Y square minus x square is the lowest degree term, right? So it is symmetric about both axes. Third, tangent about origin. So the lowest degree term is y square minus x square equals to 0. So you are having y equals to plus minus x. So this is your tangent about the origin. Up to this, is this clear? Up to this much? Is this clear up to this much? Okay, fine. So next we are checking the region. Okay, we are checking the region. So as you can see, there is no particular value. So what are we doing? Uh, we are just checking for x. X if you can see this, if y square is greater than x square is less than y square. If x square, I am checking the right hand side here. Okay, x square y square, this is always a positive quantity. Is there any doubt about the fact that x square into y square is always a positive quantity? I think there shouldn't be any doubt since it is a square quantity, right? But if you see this part, right hand side, y square minus x square, this can be negative. So what is the idea for checking the region? You have to ensure that the within the region, all the values of the curves are real. So if you see, if this x square is less than y square, then you are getting only the negative values, right? If you are getting, if you do x square is less than y square, then what is happening? This y square minus x square, this part is greater than 0. So this condition is satisfied. So if y square minus x square is greater than 0, then I am also having the left hand side as real valued. But if y square less than x square, then you are having, are you getting real values? If y square is less than x square, if y square is less than x square, you are getting negative value for the right hand side, but the left hand side is always positive since it's x square into y square. So y square less than x square, this cannot be your region. Your only possible region is y square greater than x square, that is x square less than y square. So this is your region. So irrespective of values of x and y, you have to select x and y in a such a way that x square should be less than y square. So from here also you can simplify this to mod x less mod y. Is this part clear? Is this part clear? How you are checking the region part, since you cannot get any particular values here. So what are we doing? We are seeing that the left hand side is always a positive value, so the only ambiguity can come when the right hand side is negative, then we won't get the region. So for which values the right hand side is negative? If y square is less than x square. So if y square is less than x square, that cannot be the region of the curve, since the left hand side is positive and the right hand side is becoming negative. So what is the only possible region here? That is x square less than y square is the only possible region. Okay. Now we are moving on to the asymptote part. So first tell me, does there exist any asymptote parallel to x-axis? Does there exist any asymptote parallel to x-axis for this curve? Does there exist any asymptote parallel to x-axis? Yes or no? You can simply check by putting extending to infinity. Yes, there is no asymptote parallel to x-axis, because basically what happens if you put x tends to infinity, y does not tend to a finite number, right? But the asymptote parallel to y-axis exists. So what are the asymptotes parallel to y-axis? So how can you get those? So I'm simplifying the curve in this way. Okay. So from here, what are the asymptotes parallel to the y-axis? From this part, what are the asymptotes parallel to y-axis? Can anyone tell me? If you tend y to infinity, what you have? Yes, correct. Because if you tend y to infinity, what you are having? So you are having this. So if you are simply tending y to infinity, then you are having x square minus a square. This equals to 0. So this basically equals to x equal to plus minus a. Okay. So for similarly, for the other part, you can do similarly, you can check. You will be getting that the value of y will be some complex number. So the similar way I am checking the asymptotes. The idea is correct if you are tending the values. So from here you can check the asymptote parallel to x-axis does not exist. So if you just put x tends to infinity, you are getting y equal to plus minus some imaginary number. So there does not exist any asymptote parallel to x-axis, but there exists asymptote parallel to y-axis. Is this part clear or not? Tell me. Is this part clear or not? Is this part clear? Okay. So for these two kind of curves, we have understood how to trace it. Now I'm coming into sketch of the curves. Okay. So first we try to sketch this curve. So to sketch the curve, what we have to do, we first need to find what are the corresponding asymptotes. So the curve basically has two asymptotes parallel to y-axis. Okay. So the asymptotic nature will be there. So as you can see, the curve is asymptotic. Sorry. Hi. I'm extremely sorry. Let's go to next page, please. Sorry, there's some problem with the pen. So the curve passes through origin and asymptotic. So because of asymptotic nature, this curve will continue. And again, since asymptote about minus a, similar thing. Now again, for this part also, so the clear drawing will be like this. Both passing through origin, and these are the corresponding asymptotes. Are you getting it? Why I have drawn the curve in this manner? First of all, what we have to check if it is passing through origin or not. So it is passing through origin, and again the curve is having asymptote about x equal to a as well as x equal to minus a. So obviously you are getting the asymptote in this manner, and if you substitute the values here, like you will always have pair of values. If you put x equal to something, you are always having a pair of values. That's why for the negative of a negative y-axis also we are facing the asymptote. So this is the main curve now. This is your main curve, so you can observe very much carefully why the asymptotes are like this manner. If you set some particular value of x, say I am setting x equal to some quantity c, so the result you will be getting for x equal to c, you will be getting the same result for x equal to minus c also, right? It is because the curve is simply symmetric. Similar thing for y. So that's why we are giving the asymptote in such a manner, so both the axes are being covered. So you have a particular origin point like this and this, and these are your asymptotes. So why we are having for both axes? Since the curve is symmetric. Is this part clear why the picture is like this? Everyone? Okay. So Now I suggest you can try about the first curve also. What can be the figure of the first curve? What can be the figure for the first curve? This is the curve. So I'm drawing it for you because you won't be able to show me. So for the first curve, first tell me, will the curve form a loop? As you can see, this curve will form a loop because it is passing through 0 comma 0 as well as 3a comma 0, but also it is symmetric about which axis? Symmetric about x-axis. So there will be a loop like this, but this movement will be restricted for minus a comma 0. Why? Because this is the region of the curve. Okay, and you have a asymptote, how much? That is x equal to minus a. So basically the asymptotic nature will be like this. So the only thing here is that there is a loop forming. Why the loop is forming? Because it is passing through 0 comma 0 as well as 3 comma 0, but the curve is also symmetric about x-axis. That's why a loop within 0 comma 3 is forming. Is this clear? Is this part clear why the loop is forming? Okay, fine. Thank you. So this way you have to draw. So for drawing a particular curve, what you have to do, you have to find the points, you have to find the symmetry, then you have to find the asymptotes, then you have to draw the curve. So these are for the Cartesian type of curves. You can try the rest of the curve similar way. There is no issue because similar process will be followed. No different methodology is applied here. Okay. So what we do, we move on to the polar type of curves. We move on to tracing of polar curves. Okay. So the first polar curve is given to be r square equal to a square sine 2 theta. Okay. So since we were considering the polar curves, it is now we have to root r as well as theta. Now I am checking that the curve is first I'm checking about the symmetry of the curve and whether it passes through origin or not. So can you tell me, does this curve passes through origin? Make sure you are in polar coordinate. Does this curve passes through the origin 0 comma 0? So this is passing through origin because simply if you put theta equal to 0, you are going to have r equal to 0. Okay, so this is in polar format. So when you are substituting it into the Cartesian format, but how can you put it in Cartesian format? Sorry, x equals to r sine theta, y equals to r cos theta, or vice versa, anything you like. This is just relative. You can put this y, this x also. So basically if you put theta equal to 0, you have r equal to 0. So eventually the curve is passing through origin. Okay, now we have to check for the symmetry. Now make sure this is in polar coordinates. So how can we check the symmetry? Since this is a polar coordinate, do you have any idea how can we check the symmetry? Any idea how can we check the symmetry? The symmetries are checked by rotation here. The symmetry for polar coordinates can be checked via rotation. Okay, so first you tell me, I'm writing this curve f of r theta, this as, okay, as you know r is always fixed. If I put this, is this part clear? So if I rotate through an angle pi by 2, if I am rotating through an angle pi by 2, you can see the curve remains the same. Is this clear? If I am rotating through the angle pi by 2, the curve remains the same. Any doubt regarding this? Yeah. So if you have this thing, you can say that, you can say easily that the curve is symmetric about the point. If you are setting this as pi by 2, the symmetry will be about the point pi by 2 divided by 2. Remember this point. Okay. The curve is symmetric about the line. Theta equals to how much? What you are taking, theta equals to just pi by 2 by 2, that is pi by 4. Depending on this parameter, you have to divide it by 2 to get the symmetric line. So is the idea clear how we are getting the symmetric line? First we are checking by how angle, if we are rotating, which angle we are rotating, this is remaining the same. So you divide that by 2. So basically the symmetry is about the line theta equals to pi by 4. So first I have checked it is passing through origin and you have theta equals to pi by 4. And next, can you tell me what is there any asymptote for this curve? Is there any asymptote for this curve? Make sure it is polar coordinate. So the idea of asymptote will be changing. So is there any asymptote for this curve? To have asymptote for polar coordinates, what we have to check? Any idea? So put whatever value of theta you want. Is r becoming infinite for any value of theta? Is r becoming infinite for any value of theta? Since I want to check the asymptote, I am checking for which value r is becoming infinite. That will be your asymptote, na? But there is no such value of r for which, no such value of theta for which r is becoming infinite, because whatever the value of theta is, it is sine 2 theta, na? So it is minus 1 to 1. Okay, so eventually for any value of theta, r is always finite, and since r is always finite in polar coordinate, so it is not possible for it to have the corresponding asymptote. Again I am making it clear again. So you have this curve, this sine 2 theta. Okay, so whatever value you are taking, there cannot exist any asymptote because r will be always a finite value. Next, we are checking for the intersection points. So next we are checking for the intersecting points. So if you put r equals to a, what are the value of sine to theta? This sine to theta equals to 1, right? So okay, now if you set r equal to minus a, sine to theta is also 1, but I am selecting r equal to minus a. So what can be the value? Okay, okay, I'll just tell it and leave. I'll just tell this and leave. Since you are selecting r as a negative value, the value of sine 2 theta equals to 1. This theta cannot be an acute angle. Okay, theta cannot be an acute angle. So basically, what are the other possible values of theta? The range of theta is within 0 to pi. Okay, so the other possible value is for theta is pi by 4, because you are selecting r as a negative value, so it is not possible for psi theta to be an acute angle. So what are the 2 points? One is a comma pi by 4 and another one is minus a comma 5 pi by 4, like this. So these are the points we are having. And just the next part, the region, I am not discussing the region. You can check easily for which region you are having the positive or negative values. So basically what we have to check is about the loops. Okay, so you have to check the loops. So for theta equal to 0, you are having 0, r equals to 0. Now for the point, pi by 2a. Again, if you check at the point pi by 2, pi, you are getting 0. So you are starting from the point 0. Okay, and again when you reach at the point pi by 2, you can see very carefully you are returning to 0. Okay, yeah, I'm just leaving just this last part. The loop is clear. The loop is that you have to check where for which values the I am starting with 0. Okay, and at the point pi by 2 I am checking we are having the value of r against 0. So within the range 0 to pi by 2 we are having the loop. And finally for the tangent I am just giving you the formula r d theta dr. You can calculate the tangent. So the things are here almost similar to the Cartesian but different things. You have to check r theta. The symmetry is checked by the rotation. How you are rotating the curve, that is your symmetry. If you are rotating about pi by 2, the rotation will be pi by 4. Okay. So basically about the point pi by 4, you are having the symmetry. And finally, you are checking for the tangent, that is directly by the formula. And the loop can be easily checked what you are doing, starting from a value and ending from a value, and you are checking within this range if the value is returning or not. At 0 point we are having 0, again at the point pi by 2 we are having 0, so we are getting the loops here. So similarly you can calculate the following results. So what is the idea? You have to calculate these quantities to get the corresponding tangents and the total relation for the curve. So you are getting the symmetry, then you are getting the asymptote, then you are getting the intersecting points, finally the region. You can check it yourself, it is not much difficult. The loop you are checking, you are taking a particular range and you are checking whether the value is returning or not, and finally you are calculating the tangent. The tangent can be calculated by the formula. That's it. So for the polar coordinates, you try to do in a similar way. So if you are facing any problems, please let me know. Okay. If you are not facing any problems, you can leave the meeting. Or if you are facing any problems, you can directly tell me. I'm sharing the number for now since I have taken the class. You can send me your solutions here. The parametric we haven't discussed yet. So let's see Farin ma'am, if Farin ma'am takes the class, we'll still discuss about the parametrics one. If you are not facing any difficulty, you can leave the meeting since you have class as you have told. And others, those who does not have class can tell me if you are facing any problem or not, or you can send me your solutions in this number, what you have solved. Please reply anyone. Equal to 0 or equal to 0. Then to get the symmetry, what you are doing, the symmetry is not about any axis, the symmetry will be about some angle, right? Because we are considering the polar coordinates here. So since the symmetries have to be about some angle, what are we doing? We are rotating by pi by 2 angle. So basically if you rotate about some angle theta, then theta by 2 will be the line of symmetry. Since we are rotating about the angle pi by 2, we are having the symmetry line at pi by 4. Clear? Next, what we are doing, we are checking the region, we are checking the values. So for r equal to a, you are getting theta equals to pi by 4 because sine 2 theta is equals to 1. But look very carefully, when r is negative, you cannot have acute angle. When r is negative, theta cannot be acute angle. So the range of theta is within, you know very well, it is within 0 to pi for polar coordinates. So what is the other possible value? That is 5 pi by 4. So 0 to 2 pi, since the region is 0 to 2 pi. So since you already have one value and it cannot be acute, so another one is 5 pi by 4 for this, since theta is negative. Next, we are moving on to the loop part. For loop formation, what are we doing? So for the loop formation, you are starting from some value, says 0 from you are starting, you are checking the values. Okay, you this intermediate points pi by 8, pi by 4, 3 pi by 8 are just for checking because I know the values at these points only. So you can see it is at 0, it is 0. Okay, at the point pi by 8 and 3 pi by 8, it is giving same value, and again at the point pi by 2, it is becoming 0. So there is a loop from 0 to pi by 2. And finally, you have to calculate the tangent. The tangent can be calculated by r d theta dr. So tell me if there is any problem. You can leave. I have told you can leave. If you are facing problem, you can leave. I have just recapped those things. You can leave the meeting. If you are not getting, please WhatsApp me in my number. Whatever solution you have done, rest can leave the meeting.